need to classify text into specific emotions without writing long prompt instructions. You'll see how to declare an emotion classifier in DSPy using a simple class structure that defines both the input text and the exact output labels. The code then runs inference with just one line, keeping everything clean and focused on the task.
From typing, import literal. Class emotion, DSPy, signature. Classify emotion. Sentence, SDR equals DSPy, input field. Sentiment, literal sadness. Joy, love, anger, fear. Surprise equals DSPy, output field. Sentence, I started feeling a little vulnerable when the giant spotlight started blinding me. Hash from DARE/emotion. Classify equals DSPy, predict emotion. Classify, sentence equals sentence.
This demonstrates DSPy's signature-based task declaration, where language model behavior is defined through structured Python classes rather than raw prompt strings. The code shows how to create a typed interface for emotion classification by specifying input fields and possible output values using Python's type system. The distinctive aspect is that task requirements are expressed as a formal schema that serves as a clear contract for the expected interaction. The pattern works by using the signature class to declare the semantic structure of the task, with field names establishing clear roles and type hints indicating expected data formats. When this signature is passed to DSPy, predict, it provides a structured way to invoke the language model, returning results in a prediction object that mirrors the defined schema. This creates a clean separation between task definition and execution while maintaining readability. This approach offers a more organized way to define LM tasks compared to ad hoc prompt construction. The primary benefit is improved code clarity, as task definitions become explicit components with well-defined input-output relationships. The declaration style shown here makes it easier to understand and modify task specifications, particularly in complex pipelines where multiple LM calls need to interact consistently. Let's break it down line by line.
From typing, import literal.
Imports literal from Python's typing module to declare that the sentiment field must be one of 6 specific string values. This provides static type annotation for the emotion classification output, signaling to developers and tools which emotions are valid.
Class emotion, DSPy, signature.
This defines a DSPy signature subclass that declares the schema for emotion classification tasks. It specifies a string input field named sentence and restricts the output to one of 6 predefined emotion labels, establishing the expected structure for prediction calls.
Classify emotion.
This docstring defines the signature's purpose, classifying text into one of 6 predefined emotions. It serves as both documentation and a specification for the expected input-output behavior.
Sentence, SDR equals DSPy, input field.
This defines sentence as a required string input in the DSPy signature using DSPy, input field, to explicitly declare it as a parameter the predictor expects. The type annotation and wrapper establish the schema for what callers must provide.
Sentiment, literal sadness. Joy, love, anger, fear. Surprise equals DSPy, output field.
This defines the output field as a fixed set of emotion labels using Python's literal type, restricting possible values to sadness, joy, love, anger, fear, or surprise. The DSPy output field decorator explicitly marks this as the model's prediction target, signaling to the framework which field should contain the generated result.
Sentence, I started feeling a little vulnerable when the giant spotlight started blinding me. Hash from DARE/emotion.
This defines a sample input string with clear emotional cues that will be fed into the emotion classifier. The sentence contains vulnerability and discomfort triggers, making it a strong test case for evaluating the model's ability to distinguish between fear, sadness, or surprise.
Classify equals DSPy. Predict emotion.
This instantiates a DSPy predictor using the emotion signature as its template. The resulting classify object becomes a callable that expects a sentence input and will return one of the 6 predefined sentiment literals.
Classify sentence equals sentence.
Executes the emotion classification by passing the input sentence to the DSPy predict instance. This triggers the language model to process the text and return a sentiment label from the predefined set of 6 options. The actual classification happens here, using the signature defined earlier to structure the output. DSPy emotion classification. This code demonstrates a basic emotion classifier using DSPy signature with a literal type to declare 6 possible sentiment outputs. The sentence input field accepts text, while the sentiment output field defines the allowed emotion labels, showing how DSPy signatures structure input-output pairs. A single DSPy predict call executes the classification on the provided example sentence.
The prediction that fails to choose has already answered.